at the right time. You can't be wrong, and you have to be really fast. So it's not only just about being correct, but it's also being able to be correct down to the frame. Also, I worked at Synadia on Nets for quite a while, and I got to see large distributed problems. And one thing I can say from working in that space is that I don't think people realize, this talks to me a lot about the web, is that the web is a distributed problem, and people don't seem to realize that. They think it's this happy little path for the client and a happy little path for the server, and everything's going to work out. It doesn't, so be aware. Also, I was a circus performer for a long time, and I ended up in Vegas doing shows and stuff. That's another story. We can have another talk about that. Sadly, I'm probably best known for making Datastar a JavaScript framework by someone who doesn't really like JavaScript. But you'll see why. I think I might have actually solved this because I came from it from a very different perspective. And I think that's really helpful. So for me, the browser has never been more capable and performant. It is amazing what a modern browser can do. They're doing so many really good things for you if you care about what it does under the hood. Sadly, the web has never felt heavier. It feels big and bloated and hard to use. And for example, I think a lot of this comes down to that it didn't intend to be this way, but most apps are full stack JavaScript projects. And I went and tested this before the talk, and a Next.js hello world, just to get your text on the screen, is 500 megabytes. Before you do anything, just hello world page, 500 megabytes. I want to repeat, hello world, this is crazy. Absolutely massive. Also, I have to remember that I've been doing this for quite a long time. I've earned my gray hair, and I forget that some people their careers started after LeftPad. LeftPad was a thing that happened in the JavaScript world where sites went down because of a feature that wasn't in ES6. This is crazy. The thing is, what's weird too is you have these huge dependencies in this huge situation, and it's not like, oh, I have something that I can rely on. I have this, something that's heavyweight, but now I can rely on it. If you're a Next.js developer or a Svelte kit developer or one of these other projects, that's what you are. It's not like you're a JavaScript developer. You live in these ecosystems, and they don't really talk to each other. There are some projects like TanStack that try to get around this, but it's not really what I would consider the right way to do things. So out of all of this beautiful sets of things that you're depending on, the one thing you get out of this is a lot of CVEs. The thing is, I actually just went through the ones that I thought to me, these are all cell phones. This is not adding new features to the browser. It's not extending it to do things that it wasn't doing. This is things that were completely avoidable. And some of these are critical. And if you're not from the web, you're probably like, the web sucks. It's just this is all you think about, right? But most of this has nothing to do with the web. This has to do with this ecosystem that's built up over time, gradually, not on purpose. And trust me, I get why this is. I really do, because back when this first started, when single-page applications started coming in vogue, the servers were always built with one request was one thread. So if you looked at the way Apache was built, or Glassfish, or any of the other things, this did not scale. It was not built to do async and KQ and all the other ways that you build asynchronous processes nowadays. And when you saw someone's example, they would have maps or spreadsheets or anything interesting. It was always done on the client side in the browser, right? That's how you could do it. And so the problem is you had the servers didn't really support things, and then the client started doing these heavyweight things, and it just slowly went down this path. The other thing is that once it got some headway, everyone started doing it this way. And why would you not do it that way? Everyone else already is. The thing that I ran into is I don't see myself as a JavaScript developer, but I love the web for the sandboxed deployment things. Thing in the military, it's hard to get a executable to be signed off on. It's a whole huge process, but you can have a browser and basically send content immediately and have it sandboxed. That's a beautiful thing. But when I go and look at all these different frameworks, these are just the JavaScript framework of the week. When you hear that thing, that's literally you can test all these things. The irony with this set of tests that you can do of benchmarks, none of these tests actually test from the server all the way to the client and the entire process that it goes through. They're all making these weird synthetic benchmarks and stuff, of testing who's better at like being the worst option. It's really weird. So the thing is, I for a long time, I was busy. Everyone's busy. I was black-pilled. Like I was like, it's good enough. Like I don't know. This is a bad situation, and it's really bad. So what I'm going to talk about here is basically, I think this applies to everything outside the web, but right now the web is definitely, this is 100% the problem. And there's 3 ways where things can fail that we can fix this today. It's not just this is a problem. Can be fixed. So the things I want to talk about today are optimistic updates are a lie. Custom code is imperative generally, and polling leads to stale state. So my core philosophy of building systems, coming from game dev and doing all kinds of interesting things, is a purpose-built engine plus declarative data is really where you want to be. If you have that combination of high-level data, data-oriented style things, and you have a purpose-built engine that knows how to deal with that data, that's where real magic can come. There's this guy called Dr. Hip. He did this thing called SQLite. I don't know if you guys have heard of it. But this is an example of declarative things that, to me, is magical. Because as a user, you say create index or create unique index, and you're not telling him how to invalidate his cache or like to rebalance the B tree or change the way that pages work. You're saying, I need to index because I know the intent of what needs to be in place at this time. The simplicity of that is beautiful because you, as a user, are thinking these higher order ideas, and you're allowing him all the flexibility to do the things he needs to do under the hood. To me, that's really where we want to be, is either working at the high level or the low level here. So if you're doing the web stuff, the web is already, the browsers are already a purpose-built engine for sending hypermedia to the client. It is literally a hypermedia client. That's what it is. So why do we stop using it that way? Because the thing is, a browser out of the box does all this stuff sandbox for you in a beautiful way. It has features like doing stuff for actual devices. I can tell you, setting up a GL contacts and like what you have to do per thing. There's a lot of work there. You just get that in like 5 lines or 3 lines of code. It's pretty amazing what's already there. And the nice part is, so we have a purpose-built engine, and for me, declarative code is mostly there because HTML and CSS are already declarative. You're not telling it what pixels to go on the screen. You're not telling it how to deal with flat boxes. It's right there. You're saying, this is my intent. Please render it. And the thing is, it used to suck. It's gotten better. And the thing is, now you can make things that actually work in all browsers in a proper way. Like the specs have gotten really good in the last few years. So Carson Gross, who's here, has said JavaScript has one unbelievable feature. It's in the browser. Sadly, we're kind of left with JavaScript. That's kind of the ugly duckling in this situation. We can't get rid of the duck in this situation. So what I try to do with this thing that I built called DataStar is I try to make the JavaScript part just a little bit more declarative. And that, to me, really opens up the door to how you interact with the web. So there is something that's already built into the browser, and it's native in all of them, called DataStar attributes. It's actually called custom data attributes. The problem is I named it DataStar, and it's DataStar attributes, so it sounds like it's something that is some magical thing, but it's something that's literally built into the browser. So that's where you're supposed to put code that you care about that's custom, and it ends up being just a string. We'll get into it. But the idea is all your code goes in there. The good thing about the browser, it's very lenient in what kind of stuff you can put into the browser. So you can put invalid attributes, and it'll try to deal with them. But that's the unhappy path. Like if you stay within the spec, you're allowing the browser vendor developers to actually make fast paths and do things in an efficient way. So I wanted to stay within the spec and live within how they've built things for us. So like we can fix this with the tools they've already given us. So people talk about what DataStar is. To me, it's only 2 things. I want to parse those attributes easily. I want to add reactive expressions, which are missing from JavaScript. And that's it. That's literally the part that I care about. I want to just fix those 2 things to make them more declarative, and that's it. So that right now is around 4 kilobytes. Not 500 megabytes, 4 kilobytes, because that shouldn't be that hard to do. The cool part is TC39 is this thing to bring signals into the browser. Once that happens, this is going to get about half the size. So that's a good thing. it's much smaller. The nice part is I built it like you would build a kind of like an ECS game engine system so that everything else from here on out is a plugin. So you can pick and choose however you want to build your systems once you have this declarative part in place. What I found was when I first started the Datastar website, it literally was like, here's 3 plugins that I use, here's how you write plugins, good luck, YOLO. But over time, there's certain patterns that came up, like people were asking for these things constantly. So the thing is, why did I have this problem where I'm like, I need to unblack pill myself? And so I'm working on something that's what I call a data engine, which basically is taking event buses and data sets and open ontologies and trying to bring them all together. And the problem with that is that in that universe I'm trying to build, everything is a stream, literally everything. And the web UIs of today aren't really built to do that. And I'm talking, I want to be able to show stuff in microsecond timings, and that's just not something that's normal, apparently. But for me, performance really does matter. I'm looking, just like you look at the low level, I think we can do really interesting things at the high level if we do care about our L1 caches, our heap allocations, all those kinds of things. So, for me, the axe shave was, I want to make the web UI honest, and we'll get into what I mean by that in a second. I want to remove framework ceremony. I don't want to be a Datastar developer. I don't want to be a Next.js developer. I just want to use the web and target it just like I would target WebGL. I'm not a WebGL developer or a DirectX developer. I'm a guy that's targeting that for what I'm building at this time. And the other thing is, a lot of the things that I have to do with streaming and doing compression and all these things in my data engine is the same problem in the web. So if I can solve it for Datastar and help everyone else, I can actually solve my problems at the same time. So for me, the things that are really important is facts near the authority, which means every piece of data in your system, every event, everything has a source of truth. So you need to be aware of where that source of truth is, and I think people get into a lot of headaches when they don't actually follow that. They try to wrap it or put it somewhere else. Rendering near perception just means that wait to the last second to either create the pixels or create data, leave it to the engine to actually do that as much as possible. And intent near the user. We'll go into that. Kind of comes down to don't lie, but also don't tell people when they click a button, they're not saying I'm buying this thing, they're saying I'm trying to buy this thing. And that little mental shift is really simple, but it's not the way that most web development works today. So it's been about 3 years since I did the first commits of this stuff, and the nice part is V1 is done. It's out, it's working, and unless the browser stops backwards compatibility, I don't see really any reason for that to change. And because the core idea is just those 2 ideas, I think it's really simple. The nice part is we set up a 501c3. We actually put all the code into that. We're stewards of the project, but we don't own any of the code, so it's not like it can go away. No one can take it from you, which is a good thing. And for me, this is a solved problem. I can actually get back to the interesting problems, and targeting the web is no longer an issue for me or our users. So I have to give you a little whirlwind tour of what Datastar is before I can show you why we solve it. So this is standard HTML. This is nothing interesting. So you can take your data-your key foo, and what happens is in the JavaScript, that's accessible through the element data set, E as a camel case, and then the foo value. So it's just a map of string to string. That's what you get. That's all we get as a Datastar attribute, a custom data attribute. Okay, what can we do with this? First principles. So we're going to just look at the key part of this side of the equation right now. So I can name something plugin. Okay, that's some value. Well, colon is technically valid to the spec. So now I can break it up. So I have the plugin name, and then I have a key that I can work with. Okay, that's interesting. Now, underscore, not valid for reasons, but underscore valid, or underscore modifier, that's valid. So I can have a modifier plus some argument. Okay, so if we take the full solution here, is this pretty? No. But it's what we can do and still be within the spec, right? We can take this, parse it out, we can turn this into something that a plugin can hook into and have life cycles and all this stuff. So this is still valid JavaScript, or it's valid HTML, in fact. So that's the key side. So what is the value? What are we trying to do here? And a lot of times we as developers think in functional or imperative code here of just this is the thing I need to do. But the real value for most users of things is something that looks more like a spreadsheet. Because the reason why this is valuable is because the data of what the functions are is part of the cell itself. Like, you're defining a relationship when you're doing a spreadsheet, not defining what the code's going to do. So you're defining the higher order idea. You're not saying what the dependency graph is and how these things are going to update. You're just saying, this is the relationship I want to have. And that's why half of business just runs on someone's Excel sheet on someone's laptop, right? So, of course, this doesn't seem interesting, but the fact is, like, when you change this code, you know, using Excel or something, that these things are going to update. So having something that's reactive and declarative is really valuable. So now we're going to look at this value. Now look at this side. We already kind of talked about what the key is. Just imagine what this code does. Here we're creating a signal, which is a reactive expression called count. We're going to take that count, and since reactive expressions don't exist in JavaScript, we use the $sign. So the $sign says this thing, whenever this thing changes, the rest of this plugin is going to change or get run again. So in this case, data on click is saying set the count increment 1. That's all it's doing. And in this case, we're using that count with the data set to basically set the function to the main. It's very clear, but that's all that's happening here. Same thing with here, we can actually affect attributes that are already built into the element. So here we're just saying disable if the count equals 0. Okay, so we're setting up the relationship, we're setting up what our intent is. And here we're actually saying, I'm creating a new computed thing that's a total that's going to work when you back reduce, blah, blah, blah. It's just JavaScript, but we're saying when this subtotal changes, now we have a new value called totals that's going to update too. Under the hood, we have like the world's fastest signal processor and how we do it. That part doesn't really matter as much as
that was the fucking issue.
You just define your relationships. And I think that's a really beautiful and pretty cool thing. And the nice part is if you say, oh, I want to click, the @ sign is just saying that this is an action. It means that we've sandboxed this function. It's built into DataStar, so you can see this is something that's not built in the browser. You can look right away what DataStar is giving me. Otherwise, it's just
regular
HTML. There's nothing special going on here. And same thing is that, like, you have a click, and now we added a modifier saying, hey, we want to debalance this thing, and then we use double click. We didn't like make double click. Double click exists in the browser. You don't need to wrap it. It's right there. Like, just learn it. So half of learning DataStar is learning what's already in the browser, right? So we're not wrapping things. So in that case, everything is a plugin. So when you do the thing, even though we've broken it down, for me the core is a 4 kilobyte thing. If you include all the plugins that we do in the default build, it's under 12 kilobytes for the whole thing, one-time cost. You add this from one CDN thing, and you're done. And this does 95% of all websites can be done with just these plugins, which I think is pretty neat. But let's say this is something you don't want, you can just take one of these things out. But the thing we're probably most well known, so for me, DataStar is just making reactivity in the browser. But one of the plugins that we're really well known for is these around SSE and how we deal with talking to the backend. So let's get into why I'm such a big fan of SSE and why I think it's really a pivotal thing. When people think about talking to the browser, and we're kind of well known for doing real-time stuff, but for me, it's the exact same thing as a CRUD app to real-time is the exact same solution. And the reason why that is there's something called SSE, which is server send events, but it's just a response type. It's not like it's not like WebSocket, it's not anything like that. It's just a response type. And instead of sending down text HTML, you're sending down text event stream, and then you have this little format where you say, hey, I have an event, I have some data, and I have 2 new lines. Congratulations, you guys now know SSE. Like, that's all it is. And the cool part is, like, there's a little bit of a syntax that DataStar has specific for what it needs, right? But there's one for patch elements. There's one where you want to just patch the signals, where you just send down a merge patch. Again, another format that we came up with, we were using a standard called JSON merge patch. And that's it. Like, that's what you need to actually interact with DataStar from the backend. I think that's pretty cool. The one problem with the built into the browser, they have something called event source, and it only handles GET. So when you do this SSE, it only handles GET. And if you lose connection, it automatically reconnects for you. The problem is the way they do that's pretty naive. So we end up in that 12 kilobytes in those plugins, we end up making it so it works with any method. It does export back off, retry limits. If you change your tab, it automatically closes it, and then if you change back, it automatically opens up. All these things are settable and configurable, but the defaults I think are really good, especially for caring about battery life and mobile and all that stuff, especially over 3G networks. And the nice part is still fetch. We do the minimal amount to basically interact with what's already built into the browser in the C and C++ layer. So all this stuff is just there's nothing special going on here. So the cool part is that I showed you the two little things. There's one called read signals, that basically saying I'm sending stuff from the client up to the server. There's one called patch elements, which I already showed you a quick example of. And there's patch signals. And I'd say 95% of your time for most things, you're just patching down what you want the page to look like. Under the hood, we're doing morphing, we're making things really fast and efficient, but you just say, I want my page to look like this, and you send it down from any language. And when I say any language, I really mean that because there's only 3 functions, we have SDKs for all these languages, and it's like a side project for us. Like, this is not a big deal, because there's literally 3 functions that you have to implement to actually have an SDK for that plugin. People talk about DSR needing an SDK. Really, it's the SSE part that needs an SDK if you want to do this. But again, it's just text, guys. Like, it's not that hard. And there are times when having an SDK doesn't exactly make sense. Did I actually keep it up here? Did someone... Oh, guess it's gone. So I had a little $5 ESP32 device that I grabbed and said, hey, someone was saying, I wonder if I can use this for making UIs for my embedded device. So I grabbed the $5 ESP32, and within an hour, I had, using their ESP2 libraries for HTTP, had a full DataStar real-time streaming thing working on a $5 device. That's, to me, pretty cool, because I'd never played with it, and it was not a big deal. And why isn't that the way we think of it? I don't want to be a developer that is a Next.js developer or a SPA developer. I want to be someone that can look at a target and say, I want to target the web from that device because it has Wi-Fi. So part of that comes from, we're just doing plain HTTP. It's specifically built to work with low power. People talk like, why do you care so much about performance and stuff? It's because I want to be able to do stuff like this. And most of the tools that are out there just can't. And that makes me sad. The other thing is that because of the way that we do exponential backoff and retries and build things, it works really well in like 3G networks. And I think a lot of times when developers are building things for the web, they forget to put on throttling, they forget to put on 3G, they forget to see what it looks like for people coming in and out of tunnels and all that stuff. Because if you have the source of truth is your server, you have to deal with it as if it's a distributed problem. And I think most people are just forgetting that part or just ignoring it. And I think that's a broken system we're in right now. Okay, so that was DataStar. That's like kind of the part like we'll go into. Like, how do we solve these problems? How do you stop lying to your user? So there's this thing called optimistic updates. It was kind of covered before in a slightly different way, and this is pretending that things are working when they're not. And whenever I bring up optimistic updates, people say that's how games work. They're not correct. They're wrong. There's this thing called netcode with rollback, which is how some things like fighting games can basically feel like they're really fast even though you're over a network. And what happens is it actually tries to predict what you're doing, and then if it makes a mistake with its prediction, it'll go back and work. The problem with that is that it doesn't, it only works if you have a fully deterministic game loop. So you have to have a perfect system in perfect state and then be able to replay the events. So this works great for certain kinds of games. But the problem is, this doesn't match web semantics at all. This is not how the web works and how things with forms and payments, and especially things that I deal with, like medical records, legal things in the military where you have to know that when I said I'm going to do something, you did it. So we're going to say, in this case, we're trying to buy a ticket to this cool conference called Software Should Work. Every time you see it flashing, we are lying to the user. Okay, this is how most systems work today. You click the button. You made a claim. Most systems will actually say, ticket confirmed right away, or they'll set a checkbox saying, got it. Then it goes off to the server. You're still lying to the user about having this ticket. It says, oh, I'm rejecting it. You're still lying to the user. And when you finally get the packets down, okay, now we're going to roll back. Now, most systems try, like when you see people do this with a ticket system, hopefully they're not doing this. But the problem is it happens in every single stage of web development and in web frameworks that you're like, oh, I don't trust this, or I'm refreshing the page, or I'm doing something that is counterintuitive. It's because people are constantly lying to you about where the state is and what's going on. So instead of optimistic updates, notice 5 steps. We're going to do something I call instant intent. And it seems pretty similar, but what we're going to do is we're going to do that same buy the ticket. And when that happens, since we have reactive signals on the page, we can affect the button that we were talking to, but we can also disable the rest of the page. Like those same data attributes say disabled. Well, I can do that to the different areas. I can have something show that says, oh, hey, I'm reserving the seat. I can do that instantaneously, right? In the same frame, knock that out. But then on the server, I'm going off and doing my thing. I could send updates back down saying, hey, this takes a little time. I can do that right away. Or in this case, I can just send that directly down and say seat unavailable. We never had to alert our user. We never had to make it complicated. In fact, the other way is more complicated, but yet that's become the norm. I don't understand this. Like, it's simpler. If you know where the state is, then update the state. If the state is, my intent is to buy this ticket, update immediately in the client. That's not a server action, but the response is. Okay, that's all I'll talk about. Custom code is imperative. This is something that's like, when you, on our website, we have a old school Starfield thing on our page. The thing is, to do this in the browser is pretty simple. You have this canvas element, and you're just doing imperative code. That's fine. Great. The thing is that to me is not very powerful because you're defining what this is. But there's something that's already built in that allows you to write custom elements for the page, and it's called web components. And the nice part about those is that you can literally take that, isolate that state, deal with and expose properties, and now you just have this nice star field thing. You're like, well, okay, what's the big deal there? The cool thing about that is now I can drive that, the stuff that's going on that I'm in control of, right? So I can do it from the outside. So the implementation only cares about speed, but you can drive it from the outside. And in this case, let's see, please work. So, yes, so I actually am driving this on the big screen. So the nice part is that when you're writing your element, you're caring about where the center is and how you're rendering and all that stuff, but you don't care if it's driven by mouse movements and all the thing. You're decoupling those ideas, and it makes it so nice to make cool little pieces like that. And the other part that's cool about it is now we have this thing that is available to every developer. You're not a Next.js guy to do that. You can use that element from Zig or Odin or Rock or any of these, any of these things, and you're able to do stuff right away. The problem is that the current zeitgeist is, Ryan Carnito is a well-known person. He built solid JS, and he talks about all the different things. And one of the things he says is web components are not the future. And to some degree, I think he's right, but for the wrong reasons. I think that web components are not the future for single-page applications. Like, you've already made all these bad decisions. You've already wrapped this thing. You've already made this 500 meg thing. Trying to fix it at that layer is like, you're already broken. It's not going to work. So, yeah, it's adding more steps for them, and they're not getting any of the value out of it. But if we build things in a different way and make it work so that everyone's a full-stack developer, then I just think he's wrong. Because we get reusability in anything in a spec-compliant way. And also, I think the major issue is, I've had a lot of disagreements with people, that I really comes down to most spot developers really don't decouple element state from their application state. And it takes just a little bit more work to do that correctly, and it's not that bad. So, the last problem that I think can be solved is polling leads to stale state. And in this case, so let's say this conference gets big. I'm talking, we're selling up beyond Taylor Swift, like she has to call us, right? So everyone's on board with this with Isaac. So the thing is, a lot of the times where you get into situations where something works and works fine, and then all of a sudden you don't realize, oh no, this is a logarithmic thing. MDIS was flat enough for long enough, right? And the problem is, I've dealt with situations where like people would say, oh yeah, I've tested my framework, and I'm like, well, how many connections can it handle? And they say like 10, and I'm like, well, I've tested out to like 30,000, and it's working. So I care more about like the long tail of like when you get into production, when you get into things that matter, how is it going to act in those situations? And I've just found that most frameworks just don't care about this. So the other thing we want to do is not only be performant, but we want to make sure everyone's on the same playing field. So let's say there's things where people are having the scalper situation. We want to avoid that. Is it possible to actually avoid? Yes. So the problem with polling is everyone's on their own timer, and it's usually coming from the client. Clients usually say, hey, I want to update every 5 seconds or something like that. And as your system gets more and more stuff is happening in your system, this gets slower and slower, and the actual state is always out of state. As you get more successful, you get more out of state. And that's really sucks. Like, it sucks so bad when you get successful and then you're like, oh, we have fail whales everywhere, right? This can be avoided. And in this case, what I'm trying to show is that on the server, I'm deciding to do a throttle update to the backend. So I'm doing all kinds of internal processing, but I'm going to throttle so that every 200 milliseconds, I'm sending down the same thing to everyone else. And the reason why that's interesting is that everyone is able to get the exact same thing at the exact same time. Some of this comes down to trust me, bro, of how this works, but this does work in production. And the other thing that's interesting is that without changing any of your code, without changing how your templates work, without changes like your core mechanics of your thing works, you on the back end can decide, I actually have an SLA that says the box office has to be within 200 milliseconds, but I can slow things down if we get mass traffic from some other thing. So without changing your code, you can actually do dynamic updates, and all this comes from is just putting back pressure in the right place. And if you only had an update every 10 minutes, then you just update it. And people think, oh, well, I'm opening these connections, I'm doing all this stuff. It ironically is actually less power on like a 3G device to have a read-only open connection than to be opening and closing for polling. So keeping that open is not the thing. Again, some of this comes down to trust me, but do the measurements yourself and you'll be shocked at the difference. So there's a QR code. We can play this later if you want, but there's this example that someone wrote that is basically the game of life. And the fun part about it is he does it as a meme against me because it's the worst version of this possible. And what I mean by that is it's literally each one of those grids is a div. It's like individually CSS style div. So I call it a rendering demo, like a stress test, because it's the worst idea. But the neat part is he's doing it 5 times a second, and it's on his blog server. So the interesting thing about that is that his blog server has been the top of Hacker News with this thing multiple times, and it's never gone down. And the thing is, it's impossible to get out of state with it. And it was written in 300 lines of closure. So it's not even in a really fast, like crazy fast language, but it's good enough to be at the top of Hacker News and never go down ever. So if it's good enough to do 2,500 things 5 times a second, it's probably okay for your normal CRUD app. And the cool part is because basically what we tend to tell people to do, like you can send out individual targeted things, but we actually can send out entire pages of things. So he's sending down, when he's doing that, he's actually sending down 2,500 divs 5 times. Like, it's not like doing individual updates. He's sending all of it. And the neat part is we use broadly in Z standard compression, window compression, and because most of that's going to be similar, it actually can keep track of that stuff. So instead of doing polling where if you do Z standard, you can get like 6 to 1, it's like over 300 to 1 compression ratios. So you can just logically think about how you want your app to look like, and we use the browser as our VDOM. Like, we use the compression ratios to actually build those things in a fast and efficient way. So the thing is, you just send down the page as you want it from any language and let us deal with it, and it's very fast and efficient. And the cool thing is, whether you're making a CRUD app or you're making this real-time thing, it's literally the same amount of code. You get collaboration for free. And I really do think like a Web 4.0 thing is about opening the ideas of collaboration. And for me, the difference between a CRUD app to a real-time dynamic system that's live is the exact same code. There's no difference in the code. It's not harder. It's not more complicated. It's the same thing. So why aren't we doing that? So there has to be a cost to this, right? Like, I get it. Like, I'm selling you on like the web is solved. Like, what everyone's wrong. The nice part is it's been out long enough that there's been people, like I've been using it heavily, I've been using it a lot, and it's great, but we have enough of a following now that there are people that have actually taken projects like a Next.js project and moved it over to DataStar. And they started with a 1-to-1, so they're trying to actually measure and do this as close as they could. And the thing that's interesting about this, if you go read this blog article, these are the numbers. Like, 26 times smaller, 26x, like that's not percent, that's x, right? 80x, that's the thing, faster for mobile, fewer production things, less of everything, right? It's just better in every single way. And I'm not proud of this. Like, this makes me sad. This is like my side project to solve the problems I want to solve. And there's no way that you can have the Googles and Facebooks and Vercells, and they must have the fundamental misunderstanding about what the web is and what it can do, because I shouldn't be able to beat them by this much. Like, this is not saying DataStar is good. It's just saying everyone else is in a bad state. Like, we're in a bad situation, but we need to make it better. So, this is David Nolan. He is he was in the React documentary. one of the people that helped make React popular back in the day. And the reason why, the irony is that he made it popular because he said, hey, if you do should component update and use that, basically don't render in React, you can make React really fast. I think people took the wrong things from his demos because, it is what it is. But I will say he helped make React popular, but he's moved his entire company over to Datastar, and his quote, I did not mess up on the huge, that is accurate. So he's completely explored this stuff. He wrote ClojureScript. He knows this stuff very well, and originally he was going to take some ideas from Datastar and move them over into ClojureScript. Now he just uses Datastar. We have an interview with him that was about an hour long that he was talking about how it really has changed the way that he's seen the web and what the web can do. And that's exciting to me because he's one of the people that got me into React. Good and bad. The thing is, people talk about, you can do hypermedia, but you can't do it for maps and you can't do it for spreadsheets. Well, David Nolan and his team went and took their entire company, took their React app, and they moved it over to Datastar. And it is literally a tool for making QuickBooks quick. It's called Instabook. That's they took their React app and it wasn't fast enough. And again, same kind of numbers, orders of magnitude, all this stuff, and it's just better in every way for them. It's faster and better for their customers. So they have a whole talk about this if you're into Clojure or something. It's a pretty neat talk. So the good news, we are smaller, we're faster, we're simpler, we're easier. In my opinion, it's great, and it's also we're done, which I think is great. However, we are not popular. Nobody cares about us. But one thing that I am proud of, in the nobody cares about us slide, is we have, I think, maybe 4,000 stars on GitHub, but we have 2,400 Discord users. So the ratio, if you give Datastar any bit of a chance, you're going to be on the Discord, you're going to be carrying. Because part of the thing is that you're now talking to people about how to build backends, how to build interactive content. You're not talking about what the next NPM update of the week is. That's just not the conversations. Because the cool part about Datastar, to me at least, is that when you get in there, you're gonna make your app, you're gonna do your thing, and go, that's it. It doesn't feel like a Datastar app. It feels like you interacting with the web in a declarative way. So I think that's exciting that we're not popular because there's not much to talk about, and we don't have influencers because what are we gonna talk about? But the other bad thing about us is you definitely have to unlearn what you've learned. And I have to keep reminding myself there's people, I was having a conversation with a dev the other day, and I'm like, oh, you remember how Moo Tools and jQuery did this? And he's like, dude, I was 4. And it broke my gray heart so much to have, he was right, but the thing is that I have to remember that, again, LeftPad happened and people's careers have started after LeftPad, let alone after React. So people think this is the status quo, and it's not, but you have to take everything that you've thought about what the web can do and what's possible and what measurements look like and just throw it out the window. And you have to start fresh and actually learn how the browser works. So my big thing is that I fell for the black pill of I'm not a JS guy, I'm not a developer for that. I know my low level stuff and I can't make a difference. And you can. If you see something that you think is within 5-10%, put the effort in because you might find out that your orders of magnitude better than that. And I fell for this trap, and I feel like a lot of us fall for it in other places. So speaking of this, I will say that I fell into this trap with making slides because I clicked through way too many slides. I will be making some web components for other people so that when they make slides, this will be much easier in the future. So I'm going to...
Am I not receiving emails, dude? This is really bad.
So, yeah, that's all I have to say for now. Questions?
I really like WebSockets. Am I wrong?
So you're not a plant. So I worked on, before I did Datastar, I actually worked on a thing I called, what did I call it at the time? It's been a hot minute. But I basically ported Phoenix like the Phoenix framework, over to Go, and I got deep into WebSockets. I actually have some patents related to WebSockets in the military world, and yes, you are wrong. I will happily have a whole conversation with you, but some of it comes down to basically it's not standard HTTP, all the updating and the way that it deals with things. You basically lose out on all the beauty of that's built in the browser. You lose out on compression. You lose out on all these other ideas of how headers work. Like, you don't have access to the things that are already built into the browser. So you're losing out on so much that the two-way connection thing that you're getting out of it is actually cost way more. And especially in HTTP2, because when you do multiple posts, those are all going over the same connection, and it's all getting multiplexed. So at one time, 10 years ago, 100%, I also did a lot with WebSockets. Nowadays, please don't. That's all I can say. But we can talk more.
Thank you.
Yeah.
Hello, just a quick question. You obviously do a lot of streaming events. What happens to the backend when you have a lot of streaming events? Do you have to account for more capacity, or do you have to do, because you have all of these events?
Yeah, so how many events are you talking about? Because when I do stuff, I'm looking at roughly like between 30 and 40,000 connections per core on a machine, and most people's web problems do not even start there. So, like, show me your problem, and I will happily work with you to, like, work through it. But a lot of the times what I've found is that people are using Node or Dino or Bun in the background. And the thing is that the semantics of how that works doesn't really work with the way that, like, modern asynchronous things you can build and really using all your cores properly. So, like, I think a lot of times people are building stuff in JavaScript because it's like, well, this is the easiest way to interact with the browser, so I'm just going to do it this way. But if you're building, to me, Go is like the highest level language you should use, and like most of the time, if you're building for performance, you should be in Zig, Odin, and Filcy, all these ones, and really thinking about it at that level. Because if you care about performance, then you should care about performance.
Thank you.
Sure.
Hey, quick question. So, I think I heard you mumble something about making a change to JSON merge patch.
No, so I'm just saying that we, instead of trying to say, like, we're going to make our own merge patch, our merge signal idea, we try to use the standards as much as possible. So there's already a standard called, I think it's 8601, that is JSON merge patch.
Okay, yeah. I'm using it really heavily, and I thought I heard you say you had, like, a better, faster version of it, and I was going to say I need that, but no, very good.
So one thing that I am working on, which, is slightly related, is I am working on something called RON, which is Readable Object Notation. A Star Federation is going to be under that, it's under the 501c. And basically, I'm trying to make it so that JSON is it kind of looks like Eden from the closure space, but it's actually one-to-one, and it makes it simpler, easier, faster, smaller, and compresses better, all this stuff. So I have this project called RON, which takes all the ideas that were supposed to be in YAML that are not there and are good, and actually just takes JSON and makes it smaller and easier to write. So we should talk about that.
Yeah, sounds good. Thank you so much.
Thank you.
Hey, my question is like, if your development teams grow, right, and your complexity of the UI grows, am I understanding correctly that you have like one connection to the server and the server can send updates to any of the components and replace it? So how do you maintain that complexity, ownership, and also piggybacking on that, what's like the testing story? You know, like if you have a server which essentially sends events which like your HTML thing, how do you ensure that like you're testing things end to end, and how do you ensure that like, if you have a lot of teams working on different parts of components, how they not stepping on each other's toes?
Yeah, so most of the time, unless you're making web components, which are isolatable and they can be tested on their own, right? They're completely independent. But the thing is, when you're talking about the application state and what you're sending down, especially if you're talking about the fat morph, where you're saying, I just want you to render this state. Like, here's my model, here's what my templates are, take the whole thing, render it to the page, and then you deal with focus and all this stuff so you're not losing focus. Like, then all you're sending is a string. Like, can you test a string in any testing framework? Yeah. Like, you just test the string that you're supposed to send down, and you can do that at any rate. Again, like, it's less complicated than people make it out. You're not trying to build frameworks and stuff. The browser is just updating strings, man. Like, it's a lot simpler than people are making it out to be.
All right, thanks.
Thank you.
Good afternoon. I'm mostly a back-end developer. I've stayed away from front-end frameworks for many of the reasons that you cited in this talk. And I'm wondering, is your experience with your discussions on Discord, have you seen that Betastar has been kind of like the catalyst to push more back-end people into dipping their feet into the front end?
Yeah, I'm not known for being very strategic at all. But I will say that, like, for the average web developer, I don't care if they use Datastar. I just don't care. Because the thing is, like, they're so enclosed in their ecosystem that, like, the idea that we're a JavaScript framework that will not put stuff on NPM, they like, well, then I'm not going to even take a look at it. And I'm like, okay, cool. So the irony is that if you're a back-end developer, you'll probably have an easier time with it than if you were a front-end developer and, like, having to unlearn the whole world. If you're just like, oh, well, this is just how the web works. Okay, like, this isn't that bad. I think the thing has been so scary for anyone that's cared about performance or cared about things at a deep level. Like, we have people that are talking Zig and Python and having direct conversations about how they build their backends. That to me is this beautiful, like, that's what the web should be, is this way that we all can agree on, like, higher order concepts. So if you're a backend person, you'll fit in just fine. Okay?
Thank you.
Thank you.
I don't even know. I honestly don't know what to do.
Person myself. I'm wondering if you find, as people transition from maybe React to Datastar, are those compatible paradigms in any way for like an incremental migration, or is it best to just kind of cut over?
The thing is that you put state in the wrong place. I don't know how you incrementally put state in the right place unless you just put state in the right place. I guarantee you, like, the irony is I've gotten into major Twitter feeds, or like with people that have done stuff with Next.js or said, hey, we're going to build this app this way, and I've taken it and rewritten it in Go, which is not it's a verbose language, and my code's half the size for the exact same thing. So, like, if part of that is just taking the state and putting it in the right place, you're deleting a lot of code, but you have to rethink how you build your thing. So most of the time in these front-end frameworks, optimistic updates is like the right way to build things because it's the easiest way, and that's kind of how things work, where you can't do that. Like, in my opinion, you just can't do that. So you're starting from, like, a bad situation, like, you're just herding cats all the way at every level at that pace. Whereas if you just step back and say, what am I trying to build? I think that's a lot easier. Now what you can do is that if you can find a portal of, like, almost an iframe of, like, the shenanigans that React does, and you can find a portal where you're like, just leave me alone for this one section, it'll work fine. The thing is, it doesn't take over your browser. We do a bunch of things around Mutation Observer so that we are trying to be good stewards so that you're in control of your page. You're the source of truth. But React is constantly, like, saying, no, I got it. They're trying to take those things away. So it's one of those things where we are good stewards, but they also just slam on top. It's kind of like running a Windows partition with Linux, right? Like, Windows is the one that's going to be the bad actor in that case. So that's kind of the situation we're in.
Thanks for building this and sharing it.
Thank you.
All right, everyone, please clap.
Let's get to it. We have to start with a definition. Every good talk should be an axiom is foundational statement or principle that is universally accepted as true without requiring proof. I love this because it's the mathematical version of trust me, bro. So this is coming from a wide-ranging experience. I've had a lot of different interesting jobs working on interesting projects, and I don't always know what a good system is going to look like.
Lately, GitHub has been, well, lately, not even lately, for the last, 2 years, GitHub has just been being owned in the news. Obviously, lots of downtime, poor user experience, action runners, just the worst. Just general disdain is what it feels like for the common user of the platform. And so alternatives have been gaining steam. One of them is being Codeberg. This is a platform dedicated to the free and open source software kind of environment/community. And recently, they've made a lot of news. Now, you're probably asking, well, how did a small code hosting platform make the news in such a big way? Well, it's because its members have decided, LLM projects, vibe-coded projects, are no longer allowed on Codeberg. Now, of course, this led to a bunch of tweets, people just saying all sorts of stuff, people complaining, saying this is absolutely a wrong move, some people even saying, hey, I'm stopping my donations to you, Codeberg. Okay, how dare you? But of course, as always, the internet latches onto some sort of image and then claims this is the truth when the actual truth's a little bit more complicated. So I did the extremely difficult job of actually reading the blog right here with my eyeballs from left to right, top to bottom, and I understood their arguments. And so I'm going to do my best job to kind of talk about this, and I think that they did some things really well, and then other parts I think is absolutely ridiculous, okay? Let's talk about why Codeberg is banning mostly vibe-coded projects. Yes, I did use the word mostly intentionally. Also, just a quick sidebar, nobody complained when they also, during the exact same meetings, disallowed cryptocurrency projects. In fact, this is the direct ticket right after banning mostly LLM projects. Yes, right here. You can't have projects that harm the reputation of Codeberg, such as relating to cryptocurrencies. Dude, crypto finance bros just are in shambles right now. Their boutique artisanal code hosting platform alternative to GitHub, not welcome. But before we do that, a quick thank you from the sponsor. Press down! What happened? I don't know. Did you push? On a Friday? Never! So we're gonna figure this out. How are we gonna figure this out? That's your props down? Did you guys see the wheel? New event config. I'm gonna spend a couple hours refactoring. Off with the buttons. Don't guess where your issues are. You can see exactly where they are happening with Sentry. Get all the context you need to debug any problem, because code breaks, so fix it faster with Sentry. So I think the best place to start is the terms of use. The terms of use was updated right here. This is in section 2, paragraph 7. It says the following: you must not share projects that mostly consist of code written by generative AI tools. Now, obviously, I think this is a really terrible way to word anything. What is mostly? Is mostly 51%? Is it 75%? Do they just mean a plurality? That is just like the largest portion in comparison to any other contributor? It's actually kind of a confusing phrase. And even more so, what about projects that were really beautifully hand artisanally crafted, but now are being more and more LLM generated with some light hand edits? I'm thinking of Ghosty right now, okay? Mitchell's made it absolutely clear on the internet for the last year. Lots of LLM use. So at what point does this project go from being allowed to not being allowed? Is there a line count? Is there some sort of specific measurement we can make? Or do some projects just simply get the old, you're okay, cronyism? I don't know. The second big thing they point out in this terms of use update is that there's unclear copyright status. Now, this is actually, honestly, the single best arguments against LLMs. See, LLMs, they can take code from any type of license, and you know they have, okay? I know of a very specific somebody that would really, really like to have any code and all code. Yeah! So what I mean by that is that there's things like copyleft. Copyleft means that, hey, you can use this code, but if you use that code, you also have to be copyleft. It's a viral license. That means if you inadvertently took code directly from a copyleft repository, you also would have to make your project copyleft. Now, that can be problematic. I think everybody can agree that's not necessarily what you want to see. Now, with LLMs, are you taking code from copyleft repositories? I don't know. Some countries might have different opinions on this than other countries. We're still in quite the gray area, and this seems to be the most ethical and sound argument together, which is we don't know what the license were to train on it. We don't want to ruin our project or potentially fall under some sort of EU jurisdiction or some Australian law or some law across the world in which says we can't do that. And then we have to figure out the legal problems that are kind of involved in this conundrum, this quagmire that we found ourselves in. And so to me, that actually seems to be the most clear and consistent possible active against LLM. So I actually do support this. This is a good reason. If this is Codeberg's complete reason, I totally get it, but it's not actually their full reason.
What the fuck, man?
And furthermore, have little safeguards to ensure that they do not include harmful code. Now, this one, obviously, I genuinely pretty disagree with two reasons. We've seen just a disastrous amount of CVEs and all sorts of stuff